Hey, it's Flora, and you're listening to Science Friday. Today, we are revisiting one of my favorite interviews from last year. I hope you enjoy it. I want you to focus on your hands. What are your fingertips feeling right now? Maybe it's the cool screen of your phone or the tug of your dog's leash. But how do physical forces like pressure and temperature get turned into a sensation we know and love, the sense of touch? A few decades ago, Dr. Ardem Patapoutian set out to investigate that fundamental question, the biology of our sense of touch, which was a complete mystery at the time. Through a long process of gene elimination, he identified a new class of sensors in the cell membrane that turned pressure into an electrical signal. He changed the game in the field of sensation and perception, and in 2021, he shared the Nobel Prize in Physiology or Medicine. So today we are sitting down with Ardem, a neuroscientist at the Scripps Research Institute in La Jolla, to hear about how he thinks about science, what fires him up, and what keeps him going. Ardem, welcome to Science Friday.
Thank you so much. Glad to be here.
So you made this huge breakthrough, and I think it's tempting for outsiders, anyway, to see it as destiny. Like, oh, you must have been born to be a scientist, or you always knew that this would be your path. Is that your story?
That's almost the opposite of it. It's just nothing close to it, actually. I was actually thinking of writing an autobiography, and I was talking to different people I could work with. And I quit the idea because of that reason. They kept trying to pinpoint this moment in my childhood where where this was actually destined to be true. And I just feel like, there is lots of convoluted roads and lots of luck, lots of things that no one could have predicted. I just love doing science. So I was just finding interesting questions to go after. And certainly in the early years, never thought about getting this kind of recognition.
Where did you think you were going to head? When you were a kid, did you have a vision for your future?
I didn't, but my parents, I'm an immigrant from Lebanon of Armenian origin, and a lot of folks I know in this category want a medical doctor in the family. We have two other siblings, and the others couldn't stand the sight of a cockroach, so they thought that I would be the one to become a medical doctor.
They were too squeamish for that.
They were too squeamish, but I was very eager to kill them with my feet. So I was destined to become a medical doctor. That's my story. And honestly, that stayed with me just because I hadn't found anything else till as an undergrad at UCLA, realizing that class sizes were too big and I was not getting to know professors well enough for them to write me a letter of recommendation. So I had this brilliant idea that I could work in a lab, get to know a professor, and they'll write me a letter of recommendation for medical school. And within a few weeks, I literally fell in love with the process of doing science. And slowly I realized, okay, so maybe this is what I should do.
And you were studying fruit fly genetics, right?
That's right.
In the first lab that you worked in?
That's right. I mean, ironically, I used to absolutely dislike lab classes. I think partly because you have this very limited time to do something. You know the answer already. You're just trying to do things to get the right answer, and often it doesn't work, and you have to say why it didn't work. That's no fun. Real lab work is the complete opposite. First of all, you don't know the answer. You're asking a question for which no one knows the answer, and you're designing experiments to find it. And of course, there's a lot of failure. A lot of times it doesn't work. But I find that process of thinking of the question and then designing experiments, and then once in a while you get this answer that just, hits you that, oh my gosh, this makes so much sense. And no one knows this. I'm the only one who knows this right now.
Is that the feeling that you're chasing?
That's the feeling you're chasing for sure. I mean, there's lots of other things. I love now the process of talking to my trainees and working along with them to get these ideas, analyze data, come up with experiments. But that aha moment of finding a cool result, there's just nothing like it.
When did you first feel like this is who you are, that you were a scientist, that this is, an identity you could claim?
That's so interesting you asked that, because I, for the longest time, was cautious of using the word. For me, as scientist, it was this, I didn't immediately identify with it because of my background, not thinking about it. So in public, even when I was an assistant professor, I would say things like, I'm a researcher. I wouldn't say I'm a scientist.
Was it imposter syndrome?
I guess it must be. And it took me a long time to say that, yeah, I'm a scientist. It's bizarre now that I think about it.
Why do you think that is?
As I mentioned, I was an immigrant. I came to the United States from Lebanon. At that point, as a naive 18-year-old, I didn't even know that a career in science was a possibility. And so I've kind of stumbled into it, and step by step getting used to the idea that, yeah, this is cool and I get to do this. And I write grants and get funds to do curiosity-driven research. It gets time to get used to it, I guess.
I want to go back to that moment when you came to the U.S.
Sure.
You were 18 at the time, and you were coming without your parents, right?
That's right.
What was that like for you, and how did you find yourself here?
I grew up in Lebanon. I was literally 8 years old when the civil war started there, so not the most easiest of childhoods. But the war was there. You just got used to it. But one event right before I came, a few months before I came, I got held by some militia folks. They suspected me to be someone I'm not, I guess, and they held me for a few hours. And when I got out of that situation, I literally came home and I said, I gotta leave. I can't be here anymore. And so I was already going to the American University of Beirut. I had 1 year of my college education there. So it was a very abrupt coming to US, and financially we're not very well off. So when I came to California, I was not a resident yet, but I did come with a green card because my mom's sister had been living in the US for a long time and they had sponsored us. So for a year, I had to work some odd jobs and become a California resident so I could apply and go back to school.
What kind of odd jobs?
Well, it's funny because I found job at a Subway making sandwiches and at a shoe store in a mall, 2 part-time jobs. And I really disliked it. I had a nice college life with a great social circle. And I was almost thinking of going back. It's funny how life decisions get made. You know why I didn't go back? The main reason was the day before I came here, like 30 of my friends back in Lebanon threw a massive party for me. And it was just a wonderful time. And I hugged and kissed everyone and said goodbye. And I was literally too ashamed to go back 3 weeks later and saying, oops, it didn't work out. But thanks for the party, guys. And so
pride kept you trying.
So, but while I was finding those, my through relatives and friends in the Armenian community, there was this Armenian newspaper that had an English section. And my English was not that great, but somehow I became the English section editor. And I did other things like take the newspapers to the post office. And I even got to write horoscopes, which is one of my career highlights still.
Were you a good horoscope writer?
I think so. I mean, I tried to do a good job. I would even try to write specific messages to my friends for specific months so that I get to give them unsolicited advice.
What's your sign? A question that's never been asked on Science Friday.
Libra. Yes.
That adds up.
Yes.
That adds up. In the public Nobel Prize write-up, you talk about growing up in Lebanon and living through the Civil War and this moment when you were held by armed militants. I wondered how you thought about that, if you felt it was important to share that part of your story.
Absolutely. I'll share something else with you. I mean, when I first came to U.S., being an 18-year-old guy from Lebanon, and the name Lebanon and Beirut is, of course, associated with terrorism. And I actually kind of a bit ashamed of this, but I tried to put that out of my kind of history. And I wouldn't talk about this stuff at all before.
Really?
Yeah. And in my CV, my resume, for example, I used to say graduated from UCLA, 1990. The fact that I was, 1 year at the American University of Beirut, I took it out. I mean, I thought I didn't get a degree from it, so it's not like I'm lying. But I was kind of separating myself from that just because of what I thought people would react, I guess, because of it. And but the funny thing, especially after the Nobel, folks from Lebanon and Armenia have been so proud of me and my achievements, and it touched a nerve in a way. I've gotten this wonderful letters from elementary school kids from here in Los Angeles and Armenian schools saying things like, you look like me. I never thought science was a possibility. If you can do it, maybe I can do it. And so, when you hear things like this, you kind of take a step back and say, yes, I can just stay in the lab and do my science. But if this is the example that from Lebanon, someone of Armenian origin can come as an immigrant with very little money and no idea of what they're going to do and achieve this, and if that's an example for a young kid to be involved more in research or education, then I'd be a fool not to take advantage of this platform.
President Trump has moved to make visas for skilled workers, these H-1B visas, come with a $100,000 fee. And, of course, we're seeing ICE raids across the country. And science in the U.S. has always relied on attracting talented people from across the world. Do you see this changing? What do you think the repercussions of this are?
Obviously, I feel very strongly about this. I think in today's policies, I would either not come or not make it here. I got into UCLA using Pell Grants, which, I don't even know if they exist, or if they do, it's a very smaller scale as it was. I know running a lab now is that my lab is a beautiful meeting place of people from all over the world. At any time, we have people from US, from Mexico, from Europe, from Asia, and all these, minds come together to come up with these discoveries that are, yes, curiosity-driven, but, every medicine, every health solution starts with curiosity-driven research. And this is a beautiful international effort, and we actually absolutely lead the world in this arena, and we're kind of giving it away. It's beyond frustrating. It's mind-boggling. I mean, I have a postdoctoral fellow in my lab who's from China originally. He came to United States, one of the smartest guys you can imagine. He went to Stanford for graduate school, got his PhD. He's doing postdoctoral research with me. Initially, when I talked to him about what he wanted to do next, he wanted to do research in the United States. But recently, he's applying in China. There's so much money. They treat scientists great. And he's most likely going to go back. So here's one example of someone we've invested so much effort and money to train them as a great scientist, and we're just letting them go. It just makes no sense.
Let's go back to your story. So you were bit by the science bug. You dropped the pre-med aspirations. Let's fast forward to when you started your lab. You started your lab looking at kind of developmental biology, how neurons become tuned for certain jobs. And then you switch gears to ask this sort of bigger, more fundamental question, which is looking at the kind of molecular biology that underpins our sense of touch. What was that decision like? I mean, how much was known about that question when you started, and did it feel risky to kind of switch gears like that?
Yes, it was risky. And part of the reason I think I took the jump is because I was a bit naive and was not worried about competition. I was not worried about getting into a field that I knew nothing about. If you get trained well in science, you learn to ask, what's the most important unanswered question that I have the tools to study it and find answers in the next 5 to 10 years. That's our approach. And so my thought process at the time was that the development of these neurons is very interesting, but there are so many neurons that develop do the same thing. But these sensory neurons I was studying do something fundamentally different, which is they kind of turn physics, temperature, pressure, into a electrical activity that neurons can interpret and propagate that signal. And so, but how this was done was not known. Most of biology is concerned about chemical signalings, whether it's a hormone being secreted or neurotransmitter that binds to a receptor, changes conformation, and starts a signaling process. But how do you sense pressure? That's like pretty much nothing at the molecular level was known in our bodies. And so it was very interesting. And again, I just made the leap because I thought it was a more interesting question to ask.
I mean, this gets to a question I'm interested in, which is, what traits make a good scientist? What traits are important for being a good scientist? And is naivete one of them?
I think in some aspects, I think about this quite a bit. And I think what I've seen is that you have to have quite a few different characteristics. One is you have to be a dreamer.
A dreamer.
You have to be a dreamer because if you're not a dreamer, you're not going to think big. But then you have to superimpose some practical aspects on it, which I know sound like contradicting things. But it's when I said, come up with the biggest question, but then I also said that you have the tools to solve it in the next 5-10 years. That's the practical side. I've also found that people who are read a lot of the literature of what's already known kind of primes their mind. And by reading, I mean scientific literature. They also get trained on what questions were available out there and were solved and how. So that kind of also trains your mind of how to approach questions and how to solve them. So reading a lot, dreaming a lot, and being practical.
Being a dreamer and being practical. I love that. And I mean, Ardem, Libras are all about balance.
Oh my goodness. I never thought of it that way.
The dreamer and the practical merged. It is your sign.
Wow. Okay. I learned something about myself today.
We have to take a quick break, but don't go away. When we come back, more conversation with Ardem about his research and his life in science. Hey, Flora here. We are wrapping up Science Friday's fiscal year on June 30th, and we could use your support. We're aiming to raise $100,000 to close out our budget. And with your help, I know we can do it. If Science Friday is valuable to you, if you rely on our reporting to make sense of the world, or even just to give you your daily dose of joy and wonder, please consider going to sciencefriday.com/donate to make a donation. It's fast, easy, and secure, and any amount you can swing will help to sustain us in this critical moment. I know I've said it before, but I really mean it. Science Friday can only continue with your support. That's sciencefriday.com/donate, and thanks. How do you think about picking the right questions?
I think this is the biggest thing, right? If it was easy to teach or if it can be answered in a couple of sentences, then everybody could do wonderful science. So it's very difficult because, other than coming up with a big unanswered question that you think you have the tools to answer them, things of grit and persistence and how many questions you ask at the same time, when to know when to quit. That's actually really important because some people get too attached to an idea, and as they're getting negative feedback that this is not working, they keep trying. Sometimes all of a sudden it works, sometimes it never works. So it's a complicated question, and this is a good opportunity to always mention that luck has a huge part in success in science and probably any other field as well.
Let's get into the nitty-gritty of touch. That it feels like touch is so complex. Like there are all these experiences that I might put into the bucket of feeling, but they're different. There's the pressure, the temperature, friction, irritation. Are they all connected? I mean, how do we turn them all into one sensation?
So this was a rather surprise of our findings, the consequence of it. I'll give you an example. Olfaction, to smell. Linda Buck and Richard Axel got the Nobel Prize before on finding the sensors for smell. And there are hundreds, almost 1,000 receptors for smell. Because every volatile molecule has a shape, and then you have to evolve all these different receptors to be able to recognize the different these molecules and form an image of your brain of what that smells like based on some innate and experience, for example. So people were shocked, including us, that piezo2, this single ion channel, this single sensor or receptor, is doing the vast majority of touch sensing, whether that's a gentle breeze on your hands, your hair's moving, a slight pressure on your arm. And interestingly, biologists had previously shown that there are distinct touch specialized neurons that are actually specialized to respond to very specific forms of mechanical stimuli. Some only respond to vibrations, some respond to pressure, some respond to hair deflection. But when we talk about touch, we don't actually sense these individual things. We sense touch the way we know touch, which is kind of the addition or the summation, synthesis of all these different fibers coming together to give us that impression of touch. And so one molecule doing all of this is surprising and fascinating.
I mean, that's what makes it a huge discovery, I assume, in part too. It's sort of a very important gatekeeper.
I think so. And on top of it, I think it's this idea that we talked about. And, I received this with David Julius, who started working on temperature sensation before us, and we contributed to it too. It's this idea of the unique property of translating physical stimuli into an electrical signal. Again, very unique among the rest of biology to be able to accomplish this.
You also work on proprioception, this ability to sense where your body is in space. Does that mean that a gymnast or a dancer might have sort of better sensors than I do, or sort of built different biologically?
Yeah, first of all, proprioception is my favorite sense. The fascinating thing about it is that there's many people who don't know what proprioception is. Sometimes it's called the sixth sense.
The close talkers.
Yeah, exactly. And I often thought about why is it that people don't know it. And I think the main answer I've come up with is because we can take it for granted because you can't turn it off. You can close your eyes and imagine a world without sight. But I cannot turn off proprioception. It's always there. I know where Ardem's limbs are at all times. I know what space I occupy. It's almost like at a basic level physical consciousness. And we need this so much. It's just amazing of what you cannot do if you didn't have this. So if you didn't have proprioception, I wouldn't be able to get up and walk easily. It's just something that we really need it for basic our needs. And so, of course, this is very relevant to what you asked. Our people, Michael Jordan has much better piezo2 for making all those shots compared to us. There's no clear answer that that's the case. And the reason for that is all of these senses, of course, are very complex circuits, right? So we're talking about piezo that I sometimes compare it to the switch to turn on light when you get into a room. It's that first turn on or off. It doesn't control everything. The light fixture, all of those, the wiring control the output. And so, you could easily have the same amount of piezo2, but you put, for example, because you practice more part of your brain is focused on making you as coordinated as possible in shooting a basketball. And all that stuff that's happening in your brain, the processing would make you more coordinated, for example.
Touch feels so fundamental to the human experience and very personal. Do you think that helped your work in some way? I mean, do you think it would have gotten the same attention if it had been about ion channels that did something else?
That's a fair point.
I don't mean it in a bad way.
No, I didn't take it in a bad way, but it's actually interesting you asked that because, people in the field talk about these things of who deserves a Nobel, who deserves recognition. And obviously the importance of the biology has to match what one could explain to a layperson. And so I think studying nitty-gritty of ion channels, of how a liver enzyme is activated, is not going to make into into the same kind of recognition. But I think that's also fair. This is what we care about. And also there's a misconception on if Nobel always gives things that have translational possibilities. And it's not, because the category that I received it in is in physiology or medicine. It's not and medicine. And so it could or could not be. I mean, our research ending up being very relevant for pain and many other indications. But once again, it's the recognition is for something important for biology, and I think for it being important and recognized by lay people as touch is important, of course, plays a role.
What do you still want to know about touch and sensation?
Our big direction now is we kind of use this molecule to check boxes and say, among the systems that we knew dependent on pressure sensing, like touch, proprioception, some forms of pain, even blood pressure sensing, all depend on these piezo ion channels. We're finding completely new, understudied areas of biology where pressure sensing is very important. I'll give you one example that we have a manuscript that's going to be published very soon. Is pregnancy. During pregnancy, it's known that the uterus expands hundreds of times. And we know a lot about how hormones regulating pregnancy and childbirth. But what about the pressure? There's massive amount of pressures at play, obviously, during pregnancy.
Any pregnant person will tell you, yes, there are.
Yes. And so are there instructive mechanical cues that the body listens to and uses to process this? And indeed, we found that without these pressure sensors, and there's two of them, piezo 1 and 2, only if you don't have both of them, it is in an animal model that pregnancy can go to term, but parturition, the birthing, is massively affected by this. So it's pressure sensing is required for a birthing effect. Now, I think that's a fascinating new finding that will open up a whole field now, studying what are the downstream consequences of this pressure sensing, how does it communicate with the hormonal system, and it could, of course, have very important translational aspects to it as well. And so we're actually, I think, in a more exciting place in science than where we started, where these touch sensors now are telling us all over our bodies where else pressure sensing is important for physiology. And it's just fascinating for us to just keep going. And hopefully in a few years, we'll find out that people had massively underestimated the importance of pressure sensing in our bodies.
That's fascinating. I want to talk a little bit about how to run a lab. So let's say someone comes to you with an idea or wants to join your lab. How do you think about whether to bring them on? What do you look for?
I keep coming back to this, the dreamer plus the practical, because in addition to this, being a big thinker and dreamer, I'm also looking for what they've accomplished in the past, and also practical things like how are they going to get along with people in my lab. Because, it's hard work to work in a lab. It's long hours. It's science is full of failures. A lot of things fail before they don't work. If you don't have a lab that gets along and works well together, you will notice things are not working well in the lab overall. So lab morale and getting along is very important. So again, I'm emphasizing that there's this practical aspect that I pay a lot of attention to in addition to their intellectual abilities.
This managerial aspect, I've heard from scientists that you get to a certain point in your career and your job becomes less about research and more about being the CEO of a small, multi-million-dollar organization, which is your lab, and that this is not something that scientists are trained in. Is that true in your experience? How do you think about that? And do you think that's a flaw in the system?
I think it's true if you let it. This is such an important point for me because I feel like I don't want to be an administrator. I want to be a scientist. And I also feel like if I want to be creative, I can't be very busy, just doing administrative stuff or managerial stuff. So, I usually also give advice to young scientists. And the number one rule I have on there is don't be too busy. And one of my best ideas have come from while I was hiking or running. So I really value this. And I take steps to make sure that I don't become too busy. Even with the recent recognition, I've been able to do it. And one of the ways, for example, is that I have meeting-free Tuesday. So I don't hold any meetings on Tuesday, but it's just free day to read and think. Such a luxury to be able to do this. I realize I'm lucky that I can do this, but I think for a scientist, it's just so important. If I accepted every travel invitation, I could travel every day of the year. But again, I have a rule of doing 12 travels a year and then I stop. And so again, I think one could take steps to ensure that these pressures don't turn or take over their main job, which I think is to be a researcher and a scientist.
How do you think about failure in your work?
I guess that's one thing we didn't talk about. For a good scientist, they have to be able to accept and experience failure again and again and again. And that's a trait that, I'm used to it. I accept it. And the nice thing about experience, which, as I told you, I've been running my lab for 25 years, and I could tell these to my trainees when they're struggling after a year and a half that I've seen this again and again. And you're going to overcome this. We have a method. You have multiple projects. One of them is going to work great. And so I think it's just managing failure. But there is no science without failure. Most of the experiments we do don't work. I always also say that everybody that I know got into science, yes, to help humanity and all that. But if you ask honestly, it's because people think it's fun to do science. And if it stops being fun, then why would you do it? And so, if you think something's really cool and interesting to study and you're going to say, no, it's too risky, I'm not going to do it, then you've lost the purpose of why you got into this business in the first place.
What is the purpose of science?
I mean, the first thing I would say is, science should be for science's sake. That's what it has been through centuries. And the whole idea is that society needs to trust science, that if you let people do curiosity-driven research, understand the world inside us to around us, including all the way to astronomy to biology, that incredibly important practical things will emerge and will be good for society if used properly. And so not interfering with science and supporting science is the whole idea. And I feel very strongly about this. And when for example, we have a new finding and I'm talking to a journalist, the question I always get, how is this useful? And of course, I answer the way we always think that what we find is going to have a predicted application. But I always take the opportunity to say that many scientific findings find applications and uses in ways that the initial people who found it never even imagined it. Whole CRISPR technology of manipulating DNA is a perfect example. It was how viruses infect bacteria. You could have looked at it and say, NIH should not support this. What's the relevance of viruses infecting bacteria? And here we are. It's one of the biggest new technologies that's being used very strongly in biotechnology and pharmaceutical industry. So science for science sake, and let the good things happen without us anticipating or knowing at the get-go of how that's going to work out.
What are your words of wisdom for young people getting into science or considering it as a career?
If it's a passion, which I've been lucky enough to find, then go for it. And that's the big advice of science should be fun. I'm coming back to this. And I think I see many students, young students now, worried about funding and papers being accepted, etc., and career progression. Being a little bit old school and just finding the science that you love and doing it, and all these other more practical things will fall into place.
Dream a little
more. That's a good way of putting it.
Dr. Ardem Patapoutian is professor and the Presidential Endowed Chair in Neurobiology in the Department of Neuroscience at the Scripps Research Institute in La Jolla, California, and a 2021 winner of the Nobel Prize in Physiology or Medicine. Ardem, thank you for talking with me today.
Oh, thank you so much. Thanks for having me.
This episode was produced by Charles Berquist. I'm Flora Lichtman, and thank you for listening.